Okay, so on this one, it looks like you were told, it says 2 points on the graph, so I'm assuming you were told the 6, the -6, -5, and the 0, -5. So if I were to just kind of restart it. 6, 2, 3. All right, so you were told this one and this one. So the thing about quadratics, and this is true just in general, is that they're very symmetrical. Like, no matter what kind of quadratic I draw, if I could fold this piece of paper, I could fold it along a line of symmetry. Okay, so that's what this question is asking, is about the line of symmetry. What that means is that however far this is to that line of symmetry is the same distance from here. So going back to our problem, if we want to know what the line of symmetry is, and she says axis of symmetry, I say line of symmetry. Keep in mind it's going to be a vertical line. It's going to be a vertical line. That green was just a little hard to see. And I think I've mentioned in class VUX, vertical lines have an x equals equation. So it's an x equals. So wherever we see it cross on the x-axis is where we'll do it, okay? All right, so let's count. So I'm counting from here to here. That's 1, 2, 3, 4, 5, 6. So the total distance is 6. So that means halfway through would be that line of symmetry. So half of that is 3. So now I'm going to count 3. 1, 2, 3. Right here must be my vertical line of symmetry. So if I try to draw a vertical line of symmetry, let's see if I can draw a line here. I used to be able to know how to draw stuff on here. Okay. If I try to draw a vertical line of symmetry, that was not it. Oh, there it is. Wow, it did work. If I tried to draw a vertical line of symmetry, then it's going to go, remember it passed through that point right there. We got that point because, remember the yellow? The total distance was 6. So we said it must be half of that because it's got a symmetry about it. So we counted 3 over. We put a dot right there, and it's got to be a vertical line of symmetry. So now you can look at your x value, your x-axis, and what x value is that? That's -3. Okay? All right, so that's how you got that first answer. Now the second question, if the maximum value, so maximum and minimum, those are 2 words that maybe we should talk about for just a really quick second. If you have a quadratic that looks like this, then I would say it's a minimum. And the minimum y value is, whatever that y value is. Whereas if you have a quadratic that looks like this, then we call that the maximum. Because, y value, and it's a y value is how up and down you go. So like here you are, right? Here you are on your graph. You're traveling, you're traveling, you're traveling, you're traveling, you're traveling. You can't go any higher than this point. if you keep going, you begin to go down. You begin to go down, 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 down. So as far as your up and down go, which is y value, as far as your up and down go, that's as high as it gets. Okay, so let's set these two things aside. Bring this back. So she told you that the maximum value, so we know it must look like this. We know that the maximum value is positive 2, so the y value for this is 2. That's the y value. It's x comma y. What is the vertex? Well, we have to go back and use this little guy right here. This little guy tells us our vertex, because no matter what that quadratic looks like, I'm just going to throw out a couple of examples, okay? It could have looked like that. It could have looked like that. It could have looked like that. We don't really know. We just found that axis of symmetry. But no matter where that axis of symmetry, whenever you know that axis of symmetry, then you know the x value of the vertex. Okay, so I'm going to delete all those because we don't know really what those are. Those green ones I was just making up. But we know now that the -3 is, and you wrote it here, the x value of the vertex. And so that's why you got that -3 right there. So it's -3, 2. That represents that point. So now we can come back up here. We can draw a little bit more on here. Let's continue to draw. 1, 2, 3, 4. I'm just going. All right, so my vertex is, what did we say it was? -3, 2. So -3, +2, that's the vertex. I could have put, well, I did put the dots here and the dots here. So it crosses something like that and something like that. Okay. All right, what is the equation of the quadratic equation in vertex form? All right, so vertex form, I see you have these vertex form written right here. I'm just going to rewrite that. Now, keep in mind it's called vertex form. Why do you think it's called vertex form? Okay, so it's called vertex form because this tells you your vertex. Let me, over here when I wrote -3, 2, since we were talking about the vertex, I can tell you that that is your H and your K that we're about to use, okay? Oh man, where'd that guy go? I have to write him again. Just not that big. Oh, there it is. I just want that piece. Okay, so go away. All right, so we said my vertex. Sorry, I'm rusty on this thing. My vertex is at -3, 2. So that's my H. I'm going to plug in right here. And my K. I'm going to plug in right here. All right, so y equals. Now we don't know A. That's kind of why we're doing this, is I'm looking to find A. I need to know what the entire thing is. But first, let's go ahead and put in my H and my K. X minus, all right, now what is my H? What did I say it was over here? It's -3, so I'm going to put in -3. Okay, so I'm following my formula. Close it, square it. Plus K is 2. So before I circle it and say I'm done, I want you to pay attention right here. Two negatives make a positive. So we'll just rewrite it. Y equals ax plus 3 squared plus 2. Now we still have a problem, right? I still don't know what a is. But I have an equation. And if I have an equation, I have a way to solve variables. Now, what points, I'm going to bring this up, what points do we know that exist on this quadratic? If you look at my quadratic, I've already used this point. We can't use that point again. But it told us two original points. It told us this point, and it also told us this point. Okay, so that was the negative 6, negative 5, and 0, negative 5. So my points are negative 6, negative 5, and 0, negative 5. Now, it's your choice which one you want to do. Mathematically, smart thinking says plugging in 0 is easier, but you can definitely plug in this one and you'll get the same answer for A. It just may take, you know, another extra step or whatever. All right, so I'm going to plug in 0 for x, that's your x, negative 5 for y. You ready? Negative 5 is my y, equals a. That's kind of why I'm doing this. That's my question mark. X is 0 plus 3 squared plus 2. Okay, so what I did was I plugged in this for x and y. All right, so solve. You may want to pause it. I'm going to start going a little bit faster because my YouTube is running out of time limit. But 0 plus 3 is not, as 3 squared is 9. Okay, so we have a times 9 plus 2 equals negative 5. I'm going to subtract 2. So negative 7 equals 9a. I'm going to divide by 9. And I get a is equal to negative 7/9. All right, so my final answer is y equals negative 7/9 x plus 3, close it, square it, plus 2. Okay, and then I already remember the other question. The other question said, what is it in standard form? So I'm going to move all this aside. I don't need it. So to get this in standard form, you just got to do a bunch of math. And I say just, it's not easy. What we got to do, though, is this is our first step. So first, we're going to take x plus 3. We're going to square it. So that's x plus 3 times x plus 3. So again, I got to start going faster. I think you can do that. But you get plus 6x plus 9. You might want to pause it if you want to. So this I'm going to put into here. So now we have y equals negative 7/9 x squared plus 6x plus 9 plus 2. So now you're going to distribute. Okay, again, you may want to pause it if you want to try to do it on your own. Y equals negative 7/9 x squared. Negative 7 times, that's 3, 2, that's 14 thirds. Is that right? 2, 3, yeah. X, and then minus 7, and then I still have plus 2. And then minus 7 plus 2. So for a final answer of negative 7/9 x squared minus 14x minus 7 plus 2 is minus 5.